A medical transport drone flying at 80 miles an hour detects a severe storm front ahead. In a fraction of a second, it calculates an evasive banking maneuver, checks the local airspace for other traffic, and requests an emergency landing pad at a nearby hospital. The drone secures the clearance, pays the helipad fees digitally, and safely reroutes. Yet, the physical machine in the air lacks the onboard processing to calculate global weather patterns. It does not contain an air traffic control database. It certainly doesn't hold the banking ledgers required to transfer funds. Historically, attempting to build and house all of that infrastructure internally required massive physical computing space. A machine carrying its own weather, traffic, and financial servers would crush itself under the structural weight of the hardware and data. Modern scalability solves this burden by decoupling the architecture. It separates the immediate user interface, what the drone actually does, from the vast server-side reality where the data lives. The drone operates on the action layer, crossing that narrow bridge to ask external servers for specific answers. By utilizing an application programming interface, or API, a single piece of hardware possesses near infinite capabilities. It accesses live meteorological metrics and complex banking systems instantly, bypassing the need to own the storage or processing power required to generate them. The most resilient digital systems do not hoard resources. Their capability relies entirely on mastering frictionless, real-time external connections. At dusk, a severe heat wave settles over a sprawling metropolis. Millions of air conditioning units and high-intensity lights spin out simultaneously. The automated smart city energy grid detects an immediate critical capacity drain. To prevent rolling blackouts, the city's system must automatically locate, negotiate, and secure surplus energy. Its target is a commercial solar farm completely independent of the city, located hundreds of miles away. The city sends a request to a precise digital address. Hitting the exact route mapped to the solar farm's server triggers a specific function. First, the farm demands verification. The city presents an API key. The server validates the signature, authorizing the data transfer. This secure, targeted handshake is the critical prerequisite for digital commerce. It allows two completely alien, potentially competing corporate architectures to trust each other and collaborate seamlessly without any human intervention. Once the connection is authorized, the systems communicate using a strict set of standardized digital verbs. The city must explicitly define the exact nature of the action it wants to perform on the solar farm server. Here are those commands. On the left, a GET request retrieves existing information, like checking the solar farm's battery levels. On the right, a POST request alters the state of the server, executing the actual financial purchase of the energy. The solar farm server receives the POST command and triggers its internal logic. It processes the transaction, updates its ledgers, and allocates the energy. Throughout this process, the proprietary backend code remains hidden and protected from the requesting city. For the response, the solar farm takes the complex transaction outcome and pushes it through a filter, packaging the confirmation into JSON, a clean, lightweight, universally understood data format. This uniform packaging ensures the city's grid can instantly ingest and parse the response. It does not matter what hardware the solar farm uses or what programming languages run its internal databases. Standardized verbs, protected backends, and universal packaging form a strict cycle. This allows global digital commerce to scale instantly while shielding the foundational intellectual property of the participants. That single energy transaction is a micro-example of a global mechanism. Right now, billions of these standardized, secure requests are executing concurrently across every sector on Earth. They form a vast, invisible choreography. APIs are matching compatible organ donors between continents. They are dynamically rerouting maritime supply chains around global weather events. They are settling thousands of high-frequency financial trades in milliseconds. By bypassing the need to build every tool from scratch, companies can launch products in weeks rather than years, operating with a fraction of the traditional overhead. For architects and leaders, this ability to stay lean while scaling at high speed is the core of modern business strategy. The boundary of a product has shifted. Value is measured by the vastness of the external network a system can seamlessly plug into. Building absolute empires through isolated infrastructure is an outdated model. In a landscape obsessed with strict ownership, Absolute competitive advantage belongs to those who master the architecture of connection.